Welcome to reInvent. Thank you for coming for the session. I am Fuzz, also known as Muhammad Fazlullah. Fuzz is super easy for folks to know. I am a senior developer advocate at Amazon Web Services, and I'm here all the way from dusty and hot Dubai in awesome and cool Vegas. Today's session is going to be about a developer's guide to how to get started with Go on AWS. A lot of this is based on conversations that we've had with customers, especially folks who are building Go applications, deploying them on different kind of compute platforms. But then sometimes they just need a kind of a direction of sorts of how to get started with AWS. What's the different things that's available? This is a level 200 talk, so expect a lot of resources in general, and we're going to be talking on a lot of topics. So it's going to be broad. We have a lot of references that we're going to be pointing to and also sharing that later. Also, special mention to my co-speaker who couldn't make it today, Abhishek Gupta. He and both of us actually, we built this talk, and he put in a lot of effort for this. So a lot of what you're going to be seeing is stuff that he's also built. We'll probably be sharing our contacts later. You can reach out to us, and then if you have more questions, we can take it up over there. Cool. So to get started, just a quick show of hands. How many of you are actually Go developers or enthusiasts like me? Okay, so I'll assume the rest of you are Java developers then. Nothing about Java. I actually started as a Java developer. I still do Java a lot of times, but I am an enthusiast, at least in the Go world, because of the kind of things that we see with Go being built these days, right? And we're going to talk a bit about that in the next couple of slides. Now, these are common questions that you see, and these are conversations that we have had. I've had this when I used to be a solutions architect. I have this now when I'm a developer advocate also, with a lot of developers and builders that I meet. And a lot of this is about, what's the kind of support that AWS provides for Go applications? And then things like, okay, where do I deploy my Go application? I mean, yes, I know about virtual machines. Yes, I know about Kubernetes and containers, but is there something more that AWS can provide? And we're going to be talking about one of those services. Then also about serverless development. That's something that is always taken as one of the options that folks want to choose because they just want to focus on the code versus trying to manage the servers and manage the infrastructure. And of course, not a surprise, generative AI is the norm these days. A lot of folks are coming in and asking about how do I actually build generative AI solutions? And we're going to actually have a demo about that. We're going to also go through a bit of the code. So if you're interested in how to use generative AI on AWS, stick around for that one. We also will touch a bit about databases, what are the different databases that are available, and also from a tooling perspective, what do you actually have at your disposal when you want to build and then deploy on AWS. So the references are all on a GitHub repo. This is pretty straightforward. I'm going to be sharing this at the end of the talk also, but just as a reference, you can have this because there's a lot of links. There's a lot of pointers to other resources that we're going to be having because this is a lot to cover in one session. So a quick primer for Go, and for the folks who are not Go developers yet, is that it's a statically typed compiled language that was introduced by Google in 2009. And today, over the years, if you see, it's heavily used in APIs. It's heavily used in building things like the infrastructure. It's used in DevOps and SRE teams. If anyone's used Kubernetes, well, Kubernetes is built on Go. And also, we see it being used in data processing in a lot of places, like for scripts and for pipelines, for example. Go has been a great fit for cloud-native applications, and it's because of its nature of being, statically typed, and also it's compilable. You actually get great performance. You also have a solid standard out library, and because it can compile to a single binary, you can take it and then deploy it anywhere directly, right? You get all the dependencies all bundled up together with the runtime, and then you can just run that wherever you need to. So it's easily shippable, and the language has been stable. It also focuses a lot on backward compatibility as much as possible. And it has been seen over the years with that. So one of the things that we see as a developer, if you're getting started on the AWS cloud and you want to start using it with the language of your choice, you actually look at, okay, what's the SDK support that's there, right? The software development kit. And that's kind of like where everyone gets started on the cloud. I still remember, at least in my Java days, and then a bit of .NET later, was that I actually was introduced to AWS through the SDK. And the SDK is basically libraries for building on AWS. And this is available in a variety of languages that's out there. And it's open source. You can actually have a look at the code on GitHub. And there is a consistent feature set, right, across these individual libraries. So let's say, for example, you are on one language and then you move to another language. You can probably find the same feature set over there also. Of course, the signature of the function, the method call would probably change, and for other reasons. In Go, for example, a lot of the calls that you use, if you notice in the SDK, a lot of it uses pointers, and that's also because it takes advantage of certain things that Go provides. Quickly, just as a refresher for what the request lifecycle looks like in an SDK. So the idea is that you, as a caller, probably have some code that's running and that connects to an SDK client. It will send an object, and that gets serialized into an HTTP for a HTTP request to the cloud. So you have a JSON object and an XML object that actually gets sent across to the cloud. And once you receive that response, the SDK client then unmarshals that, and then afterwards makes it into an object that can then be consumed back into your client. So pretty straightforward approach, which allows you to continue functioning within the language without you being exposed to a lot of the network calls, for example, right? You just have to do a function call, and then under the hood, everything else is taken care of for you. Now, with the SDK for Go, this has been available for quite some time. And this, like I said earlier about the SDK in general, this provides utilities. It provides ways to actually build applications faster. And this is something where recently we just announced that we are following the cadence of Go releases now for the SDK versions also. But the thing is this, right? It doesn't just stop over here. The SDK is just the first part of how you get started with Go on AWS. So once we know, okay, I've taken the SDK, I've actually built the code, I've compiled it, and I can probably test it out a bit to just stub it out and then see if it works. I actually ask the next question, right? Where do I get started, right? How do I deploy my application? Where do I deploy my application? And from a compute perspective, this is basically what you have already from AWS. So we have from a virtual machine perspective where you have a virtual machine. EC2 is basically our virtual compute platform that allows you to host an operating system. And from the hypervisor, everything from the hypervisor down below is actually managed by AWS. And then over here, the unit of work is actually a virtual machine. Then you move to the containers where you actually have a container that you build from your own. You have a Docker file, you build an image, and then afterwards you deploy it on a container orchestration service. In our case, we have ECS, which is our homegrown container orchestration service, and you also have managed Kubernetes on AWS, which is EKS. Also, in both of these options, you have a serverless approach, which is Fargate, which allows you not to focus on the infrastructure side of things. You leave that with AWS, and then you just provide us the container image and give us a bit of configuration, and then we do the rest for you. Now, there is a hybrid approach, which allows you to have the best of both the worlds, and we're going to talk a bit about that in App Runner in the next few slides. And App Runner is a great fit for running web apps and also APIs. So the idea is that it's a fully managed service. It abstracts a lot of the deployment side of things for you, not only from how the container is deployed, but also how it is accessed from the outside world. And there's a lot of language runtimes that are supported, Go being one of them. And from technicality perspective, this is how it works, right? So for example, let's say if you are in the container ecosystem and you have been using something like Fargate on AWS, this is what it would look like from a management perspective, where we manage the Fargate agent and everything below that, right? And all the way down to the hypervisor and then below to the data center. Now, when it goes to App Runner, the responsibility actually grows. So from an AWS perspective, what happens is that we take care of the load balancer, we take care of the language runtime, we take care of the deployment side of things, and all you have to do is just manage the application code, right? So you build the application code, you put that in a repository, you point App Runner to it, and then every time you push an update, then that would trigger a build, and then that gets deployed on AWS. Even the auto-scaling of containers is also taken care of on App Runner, depending on the kind of configuration that you set. So from a developer experience perspective, this is what it looks like. And so you have development teams who would be contributing to code over a source code repository, and they would then either, a couple of options is usually you build your own CI/CD pipeline first because you want to get your hands dirty, you want to get an understanding of what works, and then you realize, okay, do I really need to do all of this versus me building the code and actually writing the code? And have a look at App Runner, and then you see, okay, all right, there's an option over there where App Runner allows me to just point it to my source code repository. I give it a configuration file, which I can create through the CLI. So App Runner has a CLI where if you go to a project and you do App Runner init, that would then create a file that would then be used by App Runner to deploy based on your configuration. So the deployment is then taken care of, and then you get also a secure service URL, which is publicly exposed, which then you could use for other services to consume or for the public to use, which is what we're going to see in our first demo in a bit. So that's kind of like how it works. Now, why it helps really well with Go is because there is support for the native Go runtime from the get-go in an app runner, pun not intended. And the idea is that you can just point app runner to your Go application, to your code base, and then it would then package your Go application based on how you do the build. So you can provide the command for that, and then afterwards get it deployed. Now, you have the deployment done. Of course, your application runs, but like any other application, you want to save the state somewhere, and that's kind of like where databases come in. And first question comes, I mean, there's so many databases in AWS. Which database do I actually choose? And a lot of that depends on your use case, right? And it depends on the kind of access patterns that you're having, what's the kind of data that you're trying to store, and how you're actually going to access that data once it is stored. So we call this like a series of databases which is purpose-built. And we have a lot of examples online, and you can probably ask me later after the talk, and I can share some more resources on this one, where you talk about how you can decide based on your access patterns, you can pitch and then plug in a certain database insight. So whether it's relational all the way down to key value document in memory, and then time series and even wide column, right? You have everything. And the reason why this is important from a Go perspective is because there is support for all of this, right, in some form or the other. So for the native databases that are there on AWS, which is DynamoDB, TimeStream, and Neptune, there is support from the AWS SDK for Go, right? And this is already supported from the code. You can just plug it in and then start calling the databases, which under the hood will use the APIs that are involved. Then if you are using a service that supports open source database protocols, think, for example, memory, Elasticache, for example, Redis, or whether it is Postgres or MySQL, you can use those open source libraries directly with these services on AWS also. So that's a great way for you to have your code run in a certain, like probably on an on-prem environment, for example, and then afterwards recreate that database on maybe something like RDS. If you have Postgres on-prem, and then afterwards you create it on AWS, and then use the same drivers and then point it across. Then for databases that are built like compatible to APIs, for example, like DocumentDB, which is built with an MongoDB API compatibility, and key spaces, the open source MongoDB and Cassandra libraries also, the clients, basically, they can connect also with the key spaces and DocumentDB databases on AWS. So these are all a lot of the libraries that are available, and you can actually have a look at this. Probably you're already using this in some form or the other. If not, I mean, there's a list over here, and again, like I said, it's all going to be shared in that QR code that I shared earlier. All right, great. So I have my deployment kind of sorted out. I have my database already there. I've selected something, probably a NoSQL database, maybe DynamoDB. And then after that, the next step is, okay, now I'm having a lot of data come in. I want to build data-intensive applications, right? I want to like do data processing. And this is kind of like where, from an analytics perspective, you have options like Kafka, right? So on Amazon, we have, on AWS, we have Amazon MSK, and then we have Kinesis and also OpenSearch Service. And for things like these, you can actually use the libraries that are already available out there. So whether you're building these data processing solutions, you have a couple of options. Usually what happens is, as a developer, you would get started with the clients that are available, right? And the thing with the client is that when you use this, you get a lot of flexibility and control, but it also means you need to build a lot of logic internally to manage a lot of those streams and the events yourself, right? So whether it's retries, whether it's things like other things like trying to ensure that all the events are being processed and then make sure that they don't get processed again. You need to manage all of this yourself, but at least you have that support for clients. So this same thing is applied for Kinesis and OpenSearch, and in this case, you would want to actually start looking at, okay, does it make sense for me? Okay, I'm using a managed service on AWS. I am using the client, but I'm writing a lot of this application code. Do I instead just want to consume the events that are coming through these services, right? And that's kind of like where you can look at using one of these services as an event source for Lambda. And what you actually do then in this case is that you focus on your Go application, and then you put that probably in a Lambda function. And we see that in one of the demos where I just show, okay, a Lambda function with Go. And the idea is that you have that event coming in, and then Lambda gets triggered, the Lambda processes the event, and then afterwards it keeps on moving. So you have these options available, and the idea is that based on your use case, based on how much of flexibility that you want, or you just want to manage the code side of things, you can actually choose these solutions within this case. Now, a special mention also of DynamoDB streams, and we see this a lot, especially with folks who are trying to manage events that are coming through a NoSQL database. They would use something like DynamoDB, and in this case, you have a client-based approach using the Go SDK. You can have a Lambda function that is triggered based on a stream that's coming from DynamoDB. So for any, let's say, for example, any CRUD operation, you can actually have an event being fired, which would then trigger a Lambda function in this case. And there is a blog post talking exactly about how you can actually use this. Very useful, especially if you are in the domain-driven design kind of setup. You're having like CQRS and things like that, where you have events coming in regularly based on the transactions that are being done in your environment. Right, so quickly, I'm going to show the first demo. This is basically a recording. We'll show the other one live. The idea is that this shows that this application, a Go application, has been deployed in App Runner. And this talks to DynamoDB. And you can actually create this manually yourself, or you can also use CDK, which we'll talk about towards the end of how to provision that infrastructure, and just get it started. So it's just a great way to just see how you can actually have a simple web application run on something like App Runner. So on to the quick demo. Now, in this case, a URL shortener, like any other URL shortener, you just give it a URL and then gives you a short code. In this case, what's happening is the container kicks in, and then after it executes the code, gives the short code, and then stores that in DynamoDB. What I'm trying to do is I'm trying to create one more so that I can actually do a delete operation after this. And as far as the short code is there, I'm able to access that immediately. And immediately after that, I just do a delete, and then afterwards, it just goes off. All right, cool. Right, so to actually deploy this, there's a couple of things that you can do from a code perspective. But before that, let me just quickly jump into the code. All right, so everyone can see this. All right, cool. So this is a standard Go application. And in this case, what we have done is we have a router that's been set up that actually then is mapped to the service URL, which we have on top, which we saw in the demo quickly. All we're doing is we're creating the short code. We have basic CRUD operations in this case. And also we have things like the database code over here, which uses the SDK and allows us to then talk to DynamoDB. Right? And what we do is we have the basic stuff like initialization, where we have the table name, and we're going to talk a bit about the initialization in best practices towards the end. We take the shortcode that's generated, and then afterwards we save that in. We save the URL and then generate the shortcode back. This is basically how you would get started with just accessing attributes on DynamoDB, and then afterwards saving those records on DynamoDB. The same for when you're actually doing a fetch. This directly. So a pretty straightforward approach when you're using the SDK, and the documentation is pretty helpful. It gives you a lot of the examples and get an idea to get started immediately. And that's about it. Oh, OK, that's back. Thanks. Right, so that's a basic application that runs on Go, at least on App Runner. And just to show you how you can actually deploy this is, and I'm going to look at this because it's a bit smaller over there, is that you want to make sure that you are able to select the source code repository. And from that, you can go to GitHub. You can select one of your sources where you're actually keeping the code. So with GitHub, you select your repository. You can select the branch that needs to be deployed. And then immediately after that, you can decide how the deployment needs to be done. So by default, in this case, what's happening is that every time a code change is done from a branch, when a commit is merged, for example, that branch then triggers the build, and then after that gets deployed. Now, in App Runner, like I mentioned, you have the configuration which you can generate through App Runner CLI. You also have the option to create that through the UI directly, right? So all you need to do is select the runtime over there, select how the build is being made. So a standard Go build main.go, like for a small Go application works. And then what's the entry point for the application, right? In this case, it would be a main function. And then what's the port that it would listen on? And then just deploy that directly with the configuration. So I just mentioned, OK, I need just this much amount of CPU, this much amount of RAM, and that's about it. Everything else gets set up. I can also add on an instance role, so that allows me to actually talk to AWS services, which in this case, it's talking to a DynamoDB database. Cool, so that's with App Runner, and that's basically how we actually could get started with Go on AWS. You have App Runner kind of managing the whole deployment side of things. I have DynamoDB. I'm using the SDK, which is pretty awesome. Now, what can we actually do much more with all of this, right? So let's start a bit more on serverless, and we're going to see what you can actually do with Lambda in general. One of the things is that since Go compiles to a native binary, the Lambda support for Go is not via language runtime like Node or Java. Right? It's there right now, but it's actually getting deprecated, the runtime part. So we actually have in Lambda an option called custom runtime. This allows you to have a binary, and then you can hook into the custom runtime APIs for Lambda, and then afterwards manage the lifecycle yourself. In this case, for Go, what actually happens is that you create the binary, and then afterwards you just say, okay, fine, I'm going to use the custom runtime directly. The advantage you get is that everything becomes much smaller and from a deployment perspective. So from a support perspective, all you need to do is you need to just include the Lambda library, library support that we're going to talk about in a bit. The idea is that this gives you a way to actually get started quickly with the application that you have without worrying too much about runtimes anymore. So you can manage that part yourself. So this actually happened recently. So AL2 is an approach. This AL2 was actually as a runtime was provided last year. And just recently, a few weeks ago, we have provided AL2023. So Amazon Linux 2023 as a runtime option is available on Lambda. And this works for any language that you can compile to a native binary, right? So we have this in Rust, we have this in Go. And if you are still in the Java space, if you've heard of Quarkus and Micronaut, right? You have GraalVM as an option. You actually have that as an option where you can use a clean image, like in this case, which we're going to talk about in a bit. We're going to use a clean image and then have a build and then use that base image, the clean OS image, and then afterwards build the final container image, which you can then deploy on AWS, on Linux. So there are a couple of options that you can do with Lambda. So the idea is that you can actually take a Go function and then package it into a zip file and then deploy it. But the thing is, with a Docker image, it makes it easier for you to then test it out on different container orchestration services. Sometimes what may happen is you may have an application that would make more sense for a Lambda function because of spiky workloads, right? Because you just want to run it every time a certain request comes in, but the rest of the time it doesn't need to actually trigger. That's kind of like where you can build the image. Now, in this, you have two options. The first one is you can use the AL2 or the AL2023 base image. So all I need to do in my Docker image, I have a multi-stage build setup. I start with how to build the Go application. I write those commands inside. And then immediately after that, in the second stage, I build I provide the base image for AL2 or AL2023. And then afterwards say, OK, how do I actually execute this application from Docker? Now, if you want to use a non-AWS base image, like for example, Alpine, for example, right? For other reasons, maybe you have a certain base image that you have created, you can also do that. The only thing is the second stage actually will change. You actually refer to that base image, and then afterwards build that final image in this case. All right, cool. So that's all about deployments, right? Everything's fine in this case. Let's talk about AI apps, right? It's the in thing right now. Everyone wants to have more smarter apps these days. And the thing is with it's changing, and a lot of times when you go with AI apps, the first language that comes in, which I haven't still spoken about, is Python, right? But does that mean that Go developers like us are left out into the cold? No, they're not, right? So we have options you can do, and one of the ways you can do that is with Amazon Bedrock, right? So Amazon Bedrock is a service that we launched recently, and we've made a lot of announcements in the last few months about this. This allows you to plug into foundational language models, right? The idea is that you just get an API endpoint, you can then interact with that API endpoint using code. And we're going to show a bit of that. I think it's a pretty cool demo in that sense. And the way you get started is you use the SDK, for example, and then afterwards you include the SDK runtimes for Bedrock and Bedrock runtime packages. And the Bedrock runtime package is what you will use to interact and invoke the APIs directly on Bedrock. Now, there is a getting started guide, and that's my co-speaker who has actually created that. He's actually also created a blog post on this, really comprehensive, something that you can actually use to get started. Also, as part of building a Gen AI application, one of the things that we see is that, OK, you are calling an API, that's great, but you want to actually build a generative AI application that in production does a lot more. Right? Things like think about history, for example. Think about things like, OK, it keeps the context so that it can then continue helping you throughout the conversation or throughout the interaction that you're doing. And this is where LangChain comes in. Again, LangChain, by default, was built for Python, but there are ports available, and LangChain Go is one of those options. The idea is that with LangChain, it gives you a pluggable platform of sorts, which allows you to then add support for things like different components that you need, right? You can actually have an LLM component inside. So in this case, you can have like, okay, I'm talking to Bedrock right now, and then probably you have your own maybe foundational model hosted somewhere. For example, maybe you're having Llama, for example, from Meta, hosted somewhere else. You can have all of that plugged into LangChain. At the same time, what you can also do is if you want other components, like history, for example, right? That's part of the conversation that I'm having with the foundational model. I want to preserve the history so that every time I go back, I can continue with the context that are already there, right? And that's very common in a lot of the applications that you see these days. The thing is with this, what usually happens is with an LLM, you need to understand that when you actually talk to it, it takes in a lot of the context that you already have based on the number of tokens that it can support, right? The number of characters that it can take in. And if you want to have more tokens supported in, you need to have a place to actually store that and keep it in. The same way the LLM, when it sends back data to you, you actually want to make sure that it's able to send back data continuously in a form. And we're going to see that in the demo from a streaming perspective, what it looks like. Right, so quickly onto the demo. We are going to have some fun with Claude this time around. And and this time I'm going to plug into my environment over here. Now what I've done, at least in this application, is that this is a Go application deployed in Lambda, and this is talking to Bedrock. And the way we are going to invoke the Lambda function is Lambda also has an option where you can get a function URL on top of the Lambda function directly versus having an API gateway endpoint pointing to it. It's a great way to test Lambda functions, especially if you want to just run something quickly in this case. All right, cool. Let's see. So quickly do a build. So as part of my build, in this case, what I'm doing is, so in the previous one, we used App Runner directly. In this case, we have an option for SAM CLI. I'm actually jumping the gun on this one. But the idea is that we're going to be talking about infrastructure as code later down in the next set of slides. And SAM CLI allows you to build serverless applications faster. It sits on top of CloudFormation, and it allows you to just create a template, which you can then use. In my case, what I'm doing is I have a template already over here that creates or provisions the resources. In this case, I have like a serverless function, a Lambda function for chat. And I have a couple of policies that are there in place. And also, it talks to a DynamoDB table. We use the DynamoDB table to store the history of the conversation. And then we also have the outputs. So we'll see that in a bit once it comes up. OK, cool. All right, awesome. So welcome to the serverless AI chat. I think it's the next big app on generative AI available. And this talks to one of the foundation models, Claude in this case, by Anthropic. And what I'm going to do is I'm going to first introduce myself. Hello, I'm Fuzz. What's your name? Right, so that's Claude. And I'm from Dubai. Now, this is the basic interaction that you start with an LLM. Now, the idea is that I wanted to remember what actually I asked earlier, right? And that's kind of like where DynamoDB comes in, along with the plugin for LangChain for the history side of things. And I just ask, what's my name again? Yeah, so I told it first, so it actually picked that up based on the context that I have from before. Cool. So I'm just going to quickly ask it another question. Excuse my grammar on that one. Can you point me to resources? I guess, I mean, the way we actually search for things these days has changed a lot. We're actually becoming much nicer with our queries. Sorry. Okay, let's try this. All right. Oops. Yep, that always happens on a demo. Does work, especially when it's 10 minutes before the talk, but yeah, every demo has its own way during a talk itself. All right, cool. So let's just switch back to the actual code, and I'll. Oh, is it the Wi-Fi? Okay, and that's why we have a backup in this case over here. Okay, yeah, hey. All right, cool. So that's the streaming part, right? That's basically why I wanted to show that demo. And I think the Wi-Fi kind of kicked in a bit differently. And the idea is that with streaming, what you need to do is you need to constantly keep listening to how the LLM is actually responding back, right? So that's kind of like where LangChain has a component for that. From a code perspective, this is basically what it looks like. You can reach out to me later after the talk, and we can talk a bit more about the code if needed. But it kind of gives you an idea of how you can actually get started quickly with generative AI on Go, right? So in this case, what we have done is we have LangChain, and Abhishek, my co-speaker, he's actually created an extra plugin for using chat in LangChain Go. So that's kind of like where, and he's added that already. It's on a repo on GitHub. So we'll be sharing that in a couple of days. The idea is that, again, we have the DynamoDB table. We actually have the chat history side of things over here. This is basically where you're creating a conversation buffer that allows you to store that context within LangChain and then also on DynamoDB in this case, right? And then afterwards, you invoke that session across. So a pretty cool way, and I think there's a lot that's happening in the generative AI space that's going to continue actually evolving in this case. Cool. So let's switch back. And we'll head to the next one. Right, so we saw the whole idea with deployments, we saw the whole idea with generative AI. And the thing is now, from a tooling perspective, how can actually you be productive on AWS with Go? Right? And one of the things, again, going down the path of AI in general is you want to have a coding assistant that helps you in understanding how you can get started. I mean, if you're looking at code snippets, for example, you could actually use that. Code Whisperer is one of those examples. And there's a lot that's been happening this year in terms of support for Code Whisperer, support for having snippets of code coming in based on context that you're having. So code generation is an example. This allows you to have a toolkit through the AWS toolkit in an IDE. You can actually invoke Code Whisperer. And then afterwards get certain recommendations back on what kind of code you want to run based on prompts, right? And that's usually comments that you write in your code. There is first-class support for Python, for Java, for JavaScript. For Go, it is there, but to a certain level. So security scanning is currently not available for Go, which is available for the other languages. The idea is that you can actually have code in your IDE, and then afterwards have Code Whisperer scan that code and then suggest to you, okay, this code probably is not secure enough, and these are some options that you can actually leverage instead in this case. So the way it works is you write the code as a developer, and then afterwards you get back real-time code suggestions, and then afterwards you also have a reference tracker, and you can also do security scanning, not for Go, but for other languages also. So quickly, from a recorded demo perspective, is that I have a starting application for, I want to upload a file to an S3 bucket, right? And in this case, what it does is that it starts suggesting, okay, here's a couple of imports that I think that you should be using. Of course, the choice is yours as a developer, so you can pick what you need, and then afterwards, you could just discard the rest. So in my case, if I'm especially someone who's just starting in Go from another place, I just want to know, okay, how I can, use the different imports. I just want to provide it a starting point saying, okay, I'm going to use one of the SDKs. So here's basically what I want to use. So I'm using AWS SDK Go version 2. And then immediately after that, based on the prompt that I've mentioned on top, it starts listing down things like, okay, services S3, and then I want to also use the S3 manager because I want to interact with the S3 bucket and probably anything else. Now, I don't want any other import that's needed. So I just want